So let's have a look at the formula. I've read it's not a very nice one. Okay, it looks something like this. So the probability that x, our discrete random variable, equals x, and the x here is just any number we like. I'm just using x as a placeholder. Looks like this. Now we need to have a look at this bit here. You're probably thinking, what does this mean? Is this a fraction or what? It's not a fraction. It's actually ncx. It's a shorthand for ncx. Okay, you might have seen this in lessons. I'm not going to go over too much what it is. I'll leave that to another video where we'll explain a bit more about these notations. But on your calculator, it's most of the time it's on the divide key. So if you look at the divide key on the calculator, if you press shift divide, you'll get a C on the screen, and that's how we type this in. So say we had, I don't know, n equals 10 and x was 2. We would write 10 and then press shift divide, which will get you a C. It comes up like as a bold C. 2, okay? So that is shift and then the divide key. Okay, that's how you get that. What it actually is it's the number of it's a combinations operator. So it says how many combinations of 2 are there in 10 items is what it's actually asking. It's how many ways can you arrange 2 items if there are. Sorry, how many ways can you arrange 10 items if there's 2 items in each of the things we're looking at. Okay, so that's what that actually is, and that's how you type it into the calculator. P is our probability of success. Yeah, so that's our comes from the binomial distribution. So if we have x is distributed binomially with n and p, whatever those numbers are, the p goes in there. Okay, the n appears here and also as one of the powers here, and that's to the power of n minus x. This probably looks really nasty at the moment. Just bear with me. This will probably be a lot easier in an example to explain what's going on, and that's what we're going to do now. We're going to go back to that example we've looked at time and time again about the coin. Now we figured this out last time. It's x is distributed with a binomial distribution, 3 trials with a probability of success of 0.5. Now we wanted the probability, we're going to actually do here the probability the coin lands on heads exactly twice. Okay, so not at least twice, we're going to say the probability the coin lands on heads twice. Can you see that's what we're asking here with this probability statement? Remember, x is the number of times the coin lands on heads, and we're saying what is the probability that x is 2, so it lands on heads twice. Well, all we do is we fill in the formula. Okay, so if you compare this top line to the line we've got here, little x is 2. Yeah, that's the number we've put in. We want the probability x equals 2, and that is little x if we look at our formula. Okay, so whenever you see little x, we're going to replace that with a 2 because we want the probability the coin lands on heads twice or 2 times. Yeah. N is 3. So we've got n is 3, p is 0.5, and x is 2. Basically, all we're doing is filling that in the formula. So you get, remember this is 3c on the calculator, 2 times 0.5 to the x, which is 2, times 1 minus 0.5 to the n minus x, which is n was 3, remember, and x is 2. If you type all that in, and it's worth having a go at this on your calculator to make sure you're using the right buttons, you should get 0.375. Okay? So let's have a look at some more. Here's our formula again, and let's have a look at a different example. So we've got a fair dice is thrown 10 times. What is the probability that it lands on 6? Exactly 4 times. Well, first of all, as always, write the distribution down. Okay, we've got x. Now x is something different this time, isn't it? X is number of 6s thrown. Yeah. So we're saying the number of 6s thrown is binomially distributed with, remember the first number is n, with n is 10, there's 10 trials here, and with a probability of success, and the success is getting a 6, of 1/6. So that's P, our probability of success. And we want it to land on 6 4 times. Okay? That's this number here, the probability that x equals 4 is what we're after. Okay? So we've got n is 10, P is a sixth, and x, the number of times it succeeds, is 4 times. Okay? Now if you think about it, we've got 10 throws of a dice. It should land on 6 a sixth of the time, so we should expect it to land on heads probably about twice. But 4 times is quite a lot, so it's going to be a fairly low probability that it lands on 6 4 whole times in 10, when it should only really land on about 2 times. So all we do is plug all that in the formula. Yeah, so you can see here's n, and I've put n in there. Here's x. Yeah, all I've just done is matched all these up in the formula. So it's quite good if you can write this down as well. What's n, what's p, what's x? Okay, and then all you do is fill in the formula, type everything in, and you should get an answer. Okay, so it's only about 5% of the time we'd expect if we tossed, if we rolled a dice 10 times, that it would land on 6 4 times. Okay, it's quite unlikely. I'm afraid it gets even worse. There's also a cumulative formula. This is really quite nasty, and I'll do a separate lesson on exactly how we type all this in, because it's quite hard work. We use this when we want to know something like, what's the chance that it lands on heads at least 4 times, or it lands on heads no more than 4 times, okay? Because we're actually adding several probabilities together there. We've got a summation in here. We're summing lots of things together. So what we're saying is that if we want the probability, let's say for example that with a coin example, we wanted the probability that it lands on heads up to 3 times, up to and including 3 times. Now that's actually the probability that it lands on heads 0 times, plus the probability it lands on heads once, plus the probability it lands on heads twice, plus the probability it lands on heads 3 times. Now we'd have to use the formula we had last time. We'd have to use it 4 times, once for this, once for this, once for this, once for this, and then add them all together, and it would take ages. So instead, if your calculator is clever enough, okay, this works if you've got the Casio FX991. There's a button to do it. Basically, if you have the silver Casio calculators, they normally are able to do it. Just one of the more modern Casio calculators. You can actually input this symbol here, and it does all this adding together for you. So this sum means it's going to add together doing this formula several times. So it's just going to loop over this formula a few times. In this case, with x is 0, little x is 1, little x is 2, little x is 3. It's going to do it over and over again, so you don't have to type it in over and over again, and it'll automatically add them all together for you. We use that formula when we have the probability x is less than or equal to x instead of just equal to x. You need a calculator with that summation symbol to be able to do it, okay? If you haven't got one that does this, I'm afraid it's going to be quite difficult to do these questions. There are some other ways to answer binomial, but there's a table we can use in the formula book, but it only works for certain values, so you really need to be able to do this. So I would think about investing in another calculator potentially, or get a dedicated statistics calculator. It'll be well worth it. So this is the FX991. There is the summation button there. Can you see? It's absolutely tiny, I know, but just above, it's on the log key. So if you press shift, then the log key, you will get that some notation up, and it'll let you fill in this number on the bottom, this number on the top, and whatever formula you have in the middle. And that's what we're going to use to do this cumulative distribution. Also, I've just highlighted here as well, there is the button we were using last time, the combinations button. It's shift and then divide. But it's shift and the log button to get that sum notation up, and that's what we're going to try and use. If you're lucky enough to have a stats calculator, and this calculator I've got in the picture can do some stats, but it can't do this. if you have a dedicated statistics calculator, it might well be able to do this for you. You will just type in N, P, and X, and it will just do it all for you. It can be worth getting one of those. Again, I'll try and do a video on good ones to get and how to use them. There's nothing wrong with using stats calculators in the exams. The only issue is that if you get the answer wrong, often you've got no working written down. So that means if you make one tiny mistake in the calculator, you'll get no marks. Okay, so it is good to be able to do it with all the working, like I'm showing you here, at least to be able to check what your statistics calculator is doing, so you can make sure you've got the right answer. So let's do an example with this. There's the horrible formula again. So let's say a coin's tossed 8 times. Find the probability it lands on heads no more than 6 times. As always, write down your distribution to start with. Your first number's N. Yeah, there's 8 trials this time. Second number's P, which is the probability of success, which, assuming it's a fair coin, is going to be 0.5. Now we said no more than 6 times. Get good at writing down probabilities. This means X is less than or equal to 6. No more than 6 times means it could land it on it 6 times or 5 times or 4 times, all the way back to 0. So it's the probability X is less than or equal to 6. Okay, so we've got N is 8, P is 0.5, and little x is 6. Now, if you've got a statistics calculator, that's all you need. Throw those numbers in and it'll work it out for you. If not, we need to type in this big formula. Okay. Now, the way you do this, and as I say, I'll do a video how exactly how to do this, but press the shift and the log key. It'll get that sum up. And try and put in the bottom and the top values first. Now, these are going to be, the bottom one is always going to be 0. The top one is little x, that's 6. The top one is going to be 6, so type that 6 into the top. And now you're typing in the main formula, so make sure you've got the cursor on the calculator set between the brackets at this point, and start typing in. So remember, this is 8C. And now what do we type in for R? Confusingly, on the calculator, you need to actually type in X, because it doesn't use R like I do. It uses X. The reason I haven't used X in ours is because we already use little x for something else. So if you press the alpha key and then the close bracket symbol, that'll get you the X that you need to type in. So actually, they're going to use X here. Okay, so if you type in 8, shift divide to get the C up for this notation, and then alpha close bracket gives you the X. Okay, then we multiply by the 0.5 and do to the power R. Remember, R is X on the calculator. Okay, I know this is really confusing. That's why I'm going to do something specifically to look at this video, specifically to look at this stuff. So we're going to press shift and close bracket. So I'll write that down as well. X is shift and then close bracket. And that's how we get that up. And then we're going to multiply by 1 minus 0.5, which is 0.5 again, to the power of n, which is 8 in our case, minus r. And remember again that r is x. So we just put shift, close bracket to get the x up. If we press equals there, we get 0.9648 at the calculator, and that works that out for us. What that's actually done is it's done the probability of x equals 0 plus the probability of x equals 1 plus the probability of x equals 2 all the way up to 6, and it's done that all that for you by using that summation, this big symbol here. It's done that all for us, and that's why it's so useful. Even though it's quite painful typing in the formula to the calculator, it's done all of that for us without us having to do 6 separate calculations. Okay, so that's why it's quite useful. As I say, if you've got a statistics calculator, it will probably do all that for you, which is quite nice. But it's done all of that for us. So Hopefully that made a little bit of sense. Do go over it a few times if you're struggling, because it's not easy at all. It's probably one of the hardest bits, maybe the hardest bit in the AI statistics course. Okay, so make sure you're really happy. And I know the notation is confusing as well. Remember, this R is X on the calculator. Okay, they use X on the calculator, but we've already used X for other things, so I can't repeat it again. Otherwise, it gets even more confusing. So if I throw the toss coin 8 times, the probability that it lands on heads no more than 6 times is actually really likely, isn't it? It's probably going to land on heads 3, 4, or 5 times. So actually, there's only about a 3% chance it lands on heads more than 6 times. Okay, so that's how we figure out those probabilities.